Hey everybody, and welcome to our first Data Skeptic live stream. I guess I did something like this before, but this one is legit. We're going to start trying to do these. The stay-at-home order has set some new precedents for what we want to do at Data Skeptic, and frankly, we're 6 years now into the endeavor. We launched the podcast that most of you know and hopefully love, and we've recently launched our second endeavor, Journal Club, which we're going to do a live episode of today that you get to enjoy. But Data Skeptic as an entity is going to grow, and we're going to try and see if this video stuff is what should become part of our content. So for our first big live stream, we've titled it Our Data Pipeline. We're going to be going over a lot of the steps and tools and things that are necessary to produce our show and the ways in which we currently involve some more data sciencey tools and a system we built called Portal that helps us to produce the show and do a lot of different things like that. Portal is also about to become a member benefit. So thanks especially to all the people who currently support Data Skeptic. Your monthly micropayments go a long way in keeping the lights on and actually adding some new lights. So I don't look like I'm in quite the bunker that I actually have been working in for the past couple months. So our data pipeline is going to cover a lot of production steps, and I'm going to introduce you to a lot of the staff that works at Data Skeptic and helps with the production in various aspects, both behind the scenes and a little bit in front of that. But while we wait for everybody to log in, maybe I'll take a minute here and talk about this set. I don't know if this is going to evolve because Linda tells me we're going to be doing some renovations pretty soon. I mean, we're linked on the renovation. The timeline is just in flux, I think, and there might be a fun announcement related to it. But anyway, for the time being, this is where I work. This is where all the Data Skeptic magic happens. I've often recorded here for many years since we've been living here, and finally got my bookshelf looking good. Maybe we'll do some segments over there. I wonder if anything's big enough you guys can guess what I've got. I can see some Springer bindings, of course, from here. No doubt Russell and Norvig's up there. I got two of those, second and third edition. No Kernahan and Ritchie. I'm a little young, but I don't know, maybe we'll go through the stacks if we run out of time today. But to kick things off, I really want to start at the front end of production, and that's our audio production work. So a lot more goes into that than you might think. And I'm going to invite our associate producer, Claudia Armbruster, to join me now. And we'll have a little conversation about what it takes to make Data Skeptic. You able to join in? We'll give her just a second. Hey, welcome. And you may know Claudia from the credits, if you listen all the way to the end of Data Skeptic, but you are editing and producing and doing a bunch of different great stuff for us behind the scenes. Most notably, this video stream. This would not have come together without you as the technical director there. So thank you very much. Well, let's kick it off by learning a little bit more about you. Tell the viewers a little bit about yourself. Absolutely. Let's talk a little bit about the editing, because I think this is fun and people may not realize how much goes into it. On some podcasts, and there are different styles of podcasts. Some you just kind of record audio and you drop it out there. We do chop up quite a bit, I would say. I use the word a lot, and you remove most of those. What kind of other stuff hits the cutting room floor?
You don't want to have that whole long pause between everything. Um, oh, I think I was muted. Oh man.
Or are you muted? I'll
Oh.
jump on then. I hear you. Are you
Oh, okay.
muted?
I don't think I'm muted anymore. Oh my
All
goodness.
right. Should we go from the top? Have they heard anything? I
Okay.
think we got intros because something popped up and said you were muted while I was speaking at one point.
Oh, okay. Maybe we should I start from the beginning?
Let's just do it. Why not?
Okay. Okay.
Start again with bios, and we met on Upwork. Tell me a bit more about your background.
Oh, okay. Yes. I went to Ball State University here in Indiana. I studied music production and audio production. I studied vocal performance, so I did some singing when I was there and really focused on music. But when I left, I definitely wanted to do more audio production side, so that's where I met Kyle here on Upwork and submitted my portfolio and everything. And I've been editing their show and do a lot of, I help with the creative direction of it a little bit, help with music choices, kind of putting the show together and really collaborating with each other, which is really fun. And putting like editing the whole segments and our ads and everything together, and for Journal Club too, which is really fun.
Yeah, there's a lot to do. I used to do the editing in the early days, and there are times, especially because we interview a lot of people who maybe have had limited or no experience being an interviewee,
Hmm.
often like smart people that are researchers. I don't want to ever talk to the PR person or the CEO who just shakes hands. I want to go to the real him or her that did the cool thing. And a lot of times those people aren't necessarily the best at public speaking, although we've had some surprisingly articulate guests often on the show. But when I edited, would often cut like maybe the first 5% of some guests. You'd ask him like, how'd you get this idea? And the question starts, well, I don't know. I
Yeah.
guess probably, last Tuesday, the thing about it is when I was in grad school, and it's
Oh
like just
yeah.
when I was in grad school. So
Yeah.
um,
Oh yeah.
we're
There's
used to being edits. The live stuff might is a new venue for us.
definitely. Yeah, there's a lot of edits that go into, especially our type of show, since it is a little bit more just asking questions and you just want to get to the root of the answer and not all of the ums and everything else. Because there are some shows that just sit down and they do the hour and then it's
Yeah,
over. But yeah, this one there's I would say there's a lot of little edits, especially taking out all the long pauses and making it sound as natural as possible, even though there's some cadences that happen that aren't supposed to happen because they continued the sentence. But yeah, there's a
sure.
lot of edits that go into it. But it's not too difficult.
Well, I do want to work on some automation for that. We've talked a little bit about some of my aspirations here, but I don't think I've unrolled my grand plan just yet. Maybe we can start with some simple things. For example, Alex had a great idea about what if we took certain files, like my intros where there are pauses, we could eliminate those electronically and build that into Portal. Do you think that's a feature that would benefit you?
Well, there's a similar feature already a little bit in Logic where you can, because
Hmm.
I edit with Logic Pro X on my MacBook. Um, there's one already that you can remove silence, but sometimes it is either the threshold is too high, so it cuts out every little silence and then just chops up the whole audio, and then it's not even worth it. Or you can set it back and it cuts out the big pauses, which I use sometimes, but it could be beneficial. I guess it depends on how it works, but most of the time it's kind of easier just to follow the big long audio stream that I get, the big file, and just kind of chop it up myself from there.
Sure. I have maybe some aspirations that we could apply deep learning to this. Perhaps as a cleanup tool for one thing, like it could remove hisses and funny background noises that your typical like envelope and limiters can't get and stuff like that. And maybe, just maybe, by the time we get to season 40 or whatever it is, we can auto edit the show. Do you think, can I make you obsolete? What do you think are the possibilities here?
Of course, I would like to say no, but one thing for sure, I would think that I would not be out of a job just quite yet on is because you talked about having something that would take out ums
Mhm.
and ahs and things like that, especially in the English language. We say like, "Oh, I would like a Snickers bar," and we kind of use instead of like a Snickers bar. You know what I mean? So I
Mhm.
could see where it would get kind of confusing and take out. Because even when I'm editing, sometimes I want to take out an but it clearly makes sense, but I just think it's like an you know. So that could be something that could get kind of tedious because they both sound pretty similar on like
Absolutely.
what context in the sentence it makes sense in. So I think that I wouldn't be obsolete just yet. And also the way when you edit, when people are going off on a tangent, but you want to go back, or when they have the long pauses, kind of knowing that we all speak to each other all the time, so we kind of know the natural pauses and the natural cadences, and we can kind of make it sound more human and more natural, like with the real pauses that you kind of need, like a little breath or a little, so it's not just robotic, chopped up, all like no breath, no pause, idea after idea. So like when
Mhm.
I edit the show, I like to leave a few pauses, just a little breath so the listener can think about what they just heard instead of just constant running, because we always take breaths, we take pauses, we listen to that naturally. So I don't know if a machine could definitely do that as naturally as I would be able to.
Well, I think you raised some excellent points, and we're certainly nowhere near it, at least in the technology available to podcast. But I'll say this. Whenever anyone says, "Hey, I don't think a machine can do X," we actually love that in the machine learning community
I bet.
because the turnaround time's getting really slow or really fast, actually, on a lot of that stuff. So time will tell, because at the end of the day, the input is an audio stream, and your actions are mouse and keyboard inputs. So
Mm-hmm.
it's a mapping from audio to transformations,
Yeah.
but one that, as you say, requires a lot of context. So I don't know how far we'll get, but maybe that'll be an experimental project.
Oh yeah, and especially when we talked about how running through Isotope and cleaning up like that audio. I know you want to automate that too, right?
Right.
Cause I know when I do that sometimes I throw the whole audio in there, like the whole set file ready to go, and try to clean it up, and then it kind of distorts it a little bit instead of like
Sure.
going in there and like really kind of picking which ones like I would do instead of like
Yeah.
doing the whole thing like in one go, because that's what I imagine the machine would do instead of like nitpicking. But it
Well, time
depends.
will tell.
Yeah,
Yeah, I
time
guess
will tell.
the real solution is going to be, can we develop something that satisfies you as a user, but is really a human in the loop? It's a tool
Mm-hmm.
for you, not a replacement. So
Yes, I would like
just
that.
like you have those tools like Isotope, if we can provide something a little bit smarter to clean up, maybe there's something there. I'm going to sync up with Alex on some of those ideas later in this stream. I think we're on to something.
Mm-hmm. Definitely.
But in the meantime, I think we're going to keep the show rolling and bring in Vanessa. Any last thoughts, Claudia?
Nope. That's good for
All
me.
right.
I had a good time talking with everybody. Hi,
Thank
Vanessa.
you so much. Hey, hey, welcome to the show,
Hi.
Vanessa.
Neat.
Hi.
You will also know her from the credits if you listen to the end of Data Skeptic and pay attention. There, I call her our guest coordinator, which is absolutely true. This is one of the things Vanessa helps with, but you help on a number of fronts. So I'm really glad you could make it today and people could meet you a little bit.
Yay.
Why don't we get started and just tell us a little bit about yourself?
Okay, a little about me. Well, my name is Vanessa. I live in Chicago. I met Kyle in 2004, 2005. So he would talk to me about things that to this day I still don't understand. Really don't get it. But I studied photography at Columbia College in Chicago. I've had many jobs that they're all super irrelevant to data science, I think. I'm the
In
least
in
data science
academia, we
person.
just would say you're a polymath. That's the
There
term.
we go. That's what I am. But yeah, so that's about my background for sure. Not much data
And
science needed.
here's a curveball ball for you then. Have you learned anything working with Data Skeptic?
Yeah, well, I've learned that you guys have your own social network. It's called GitHub. I still don't know how
Yeah.
to really use it, but so many times I'm like trying to find people that we want to have on the show. And I'm like, oh, I'll just go on their GitHub. Everyone's got a GitHub. It's like, why is it so hard for me to find your email address? I want you on my show. I mean, Kyle's show. But why
All
won't
of
you
our
let me
show.
find you? Why won't you let me find you? But that's just one of the things that I do, go on GitHub to look for that. I do guest coordination, but also I do other things like work on the store, and also like I just try to keep Kyle's life in order. And by that I mean one day I like sent him to a dentist office, and he came out and told me that he thinks that the tools they use are like that of Castaway. You know, when he had to extract his tooth with a ice skate. So I'm sorry, Kyle, that I did that to you, but we
All
won't send you
good.
there next time.
My schedule gets complicated. You got to find the dentist that can fit me in.
Yeah, for sure.
Speaking of the store, I want to give a quick screen share and bring that up. You've been helping us get the new store in place. We had one a while ago and took it down for various reasons, and it's time to make a big comeback. So
Oh, it
let
looks
me,
great too. It's super fun.
yeah, I'm going to share. Give me 1 second and see if my sharing's good. I don't know if anybody's getting that. Let me see if I can pull up the stream on
Oh,
my other machine. All right, cool. We're good to go. So this is our store as it is today. We've got a handful of stuff in here. We're adding new things all the time. Vanessa, do you have a favorite?
Oh my God, yes. The very last thing on there is I just put it up. It's my favorite thing. It's a hoodie that in the front has the little Data Skeptic logo. You can't see it in the mock-up, but on the back it has Adam, and Adam is somebody that we all need to meet. He's our little mascot. I'm wearing my hoodie right now. I can model it for you.
Oh, fantastic.
But it's my favorite thing. And actually, one cool anecdote on that is I wore it when I went to go have dinner with Kyle, and he walked away from the table and came back, and he told me how cool it was to see Adam sitting there at the chair.
Heck yeah. We all actually on the team, I think, have come together in liking Adam. He's our mascot, and he's going to be a little bit more than that. You're going to eventually be talking to him in the next couple of months, and he'll be coordinating a few things for people, but all that to come. So if you like the show, a couple ways to support it. Come on to store.dataskeptic.com. There you can find these items and more. And the other way you can support us is through our membership. Vanessa, tell us a little bit about the membership program.
So the membership is pretty much similar to that of if you listen to a podcast and they have something on like Patreon. So you're going to give a certain amount of money per month to help us sustain the podcast. And also we have some new membership bonuses that are going to be shown throughout this entire live stream. So it's super cool. We're going to have some bonus content, some pictures that I took on there, some cool podcast logo art that you can download. So there's lots of cool stuff on there and things that I don't know how to use still, but I'm excited to learn and become a little data scientist myself.
Absolutely. In fact, this is the switcheroo of the whole live stream. We are launching, kind of relaunching our membership service, but adding in what might be an atypical kind of bonus for people, and that's what we call Portal. So, Vanessa, any final thoughts? I'm going to grab the screen and give people a quick Portal tour once we're wrapped. I feel like I rushed through some of our meet and greet. Any anecdotes you want to share?
Oh, everyone wants me to share this one particular anecdote on the team, and they're going to really love it. But I just want to tell a story of like the first time that I ever saw Kyle. I went to Kyle's house. He was living in a little house in the south side of Chicago where you would never imagine someone like Kyle would live. Just this particular block. So his let me just give you a little visual here. His living room was painted in checkers. So
Yeah,
anyway,
it was the ska house.
It was a ska house. But so I walk in and I see this guy and he's doing renovations, I don't know, 10 p.m. or something like that. He's pulling the light fixture out in his kitchen. But he didn't turn the power off. There were sparks everywhere. My God. And I thought to myself, he's a scientist? like what kind of scientist is he? I don't understand the concept. Why is the electricity on? I'm confused. But it was the greatest thing that I've ever seen, and I lived that moment in my life over so many times. I love it.
That socket was not wired to code, and as a Chicagoan, I had a fair assumption of a 3-prong socket being wired. Anyway, we're all still alive.
It was great.
Those
but anyway, if I could just wrap up and say, if you're out there writing papers, make sure your email's on your GitHub because we want to hear from you on the show.
And pull the main breaker before doing any electrical changes.
Especially that.
Those are our 2 lessons. Thank you so much, Vanessa. It's been a pleasure having you on the team.
Yay, thank you.
All right. We're going to warm up a little bit for George to come on. But in the meantime, like I said, I want to give you guys a quick tour of Portal and some of the member benefits. So to begin with, if you head over to portal.dataskeptic.com/members, that's the special link that's going to get you a membership deal. We're going to be expanding what Portal is and opening up lots of different stuff, but our live stream special, everybody's all access $5. Just come right now. That's going to change next week, but get in at the $5 level. Let me tell you what you get. Once you sign in to Portal, you'll have a dashboard not quite as fancy as mine because I've got a lot of upcoming stuff, but you'll have a folder for member benefits. In here, we have added a bunch of stuff, and we're going to keep adding more fun things as time goes by. So for example, Claudia, she does the edits, has created a ad-free version of every episode. So if you'd like to listen to the show, but not the ads, you can do that now as a member. We're going to be making some upgrades where that's its own RSS feed and all that kind of stuff. And you'll be able to get that RSS feed in here. For now, you just get the MP3s. We've got some miscellaneous art in here, different things we've used on the show over time. Maybe some of you will recognize this alternate cover that we used in the first, I think, years 2, 3, and 4 of the show, maybe. Some other fun stuff, like maybe you want to use our famous Turing machine alternative logo as your Facebook header piece. In fact, I got to get this up there. It looks pretty cool. I want that on mine. So we just share all this kind of like little assets if anybody wants to check it out or set it to their background in art. In Journal Club, what have we got in here? Oh, this actually I'm going to come back to because Sophia's got a surprise to tell us about that. Music. The current theme I didn't put in here because it's a band's theme and I have permission to use it on the episodes, but didn't want to take too many liberties. But the original theme song and a lot of the originals for the show I actually created, so I put these in here. The natural language processing theme was done by an actual professional musician. So David, thank you for doing that. And of course, we have the rights to that. So if anybody wants to go revisit those days or I don't know, use that as some background music, you've got our natural language processing theme. All the papers we've been covering on Journal Club, we're going to move them into this folder and keep adding them here. So you've got one convenient place to do your reading if you read along with us. And the members folder is just going to be a place that expands with different fun stuff we put in here. Oh, this is like I gave a talk earlier this year at UCLA and Vanessa took some great pictures. So a lot of fun stuff and some interactive things coming as well. This is going to grow and at least on a monthly basis, get new stuff in here, maybe get up to weekly or sooner if we have a lot of signups. But Portal is not just this file share, interesting, fun thing. Oh, no. It's much more than that, actually. In the same way that you can explore stuff we have in this system, on your dashboard here, you'll get something called My Files. So I have my own set of files. And this is actually where we do a lot of the work that it takes to get things done at Data Skeptic. So part of our editing process, that normalization thing Claudia was talking about, we can do in here. We have a lot of text processing tools that we built while we were doing research for our natural language processing season. So let me do a quick demo of one of those, and I'm going to bring George in. Here I am at textfiles.com, the site of the famous Jason, forget his last name, but he has a good podcast. Let's just grab some random text file, maybe something out of science here. What looks good? How to be an astronaut. I'm just going to make a new file here. Let's call this Astro. And let's paste that and save it. So, okay, we're giving you a tool to make files just like you could have done on a computer for the last 20 years. Why is this special at all? Well, we also give you certain transformations. So we want to do some NLP on this. We can compute some text stats for you. What does that look like? It runs through and does some analysis of some standard metrics like the Flesch-Kincaid reading measurement, smog index, all these sorts of common metrics you might want to do or use for feature engineering work or just general sort of exploratory analysis. Any text file or markdown file you put on here will compute all those for you automatically. And if you'd rather have the JSON, that's all provided for you too, but we just have some nice formatting. We can even add that to our search. So let's go ahead and index that and see if astronaut comes up. Did I type something wrong? Oh, my paste isn't working. Let's skip ahead while I work with my keyboard. But short story here is that Portal is a data transformation tool. So once you sign up, go ahead and upload a few files as I've done here and just play around, see what you get. And we're going to do some of that during the live stream. But enough of that. Let's move on a bit. George, welcome to the live stream.
Hi, Kyle. Hi, everyone. I'm George.
And
so
thank you for staying up late.
No problem, no problem. My brain's on LA time, so it's fine.
Wonderful. Well, George, many people will know you from being a panelist on Journal Club, but even if they don't, or for those that don't, let's go through a little bit of your background. Tell me about your education and training and things like that.
Yeah, sure. So I'm a data science student based in London. I've just finished up my third year of a computer science degree. The first 2 years were straight computer science, but I had sort of a background interest in machine learning. Initially, it was even before my degree, my interest was mostly in genetic algorithms. I loved these evolution simulation videos on YouTube, and I was desperate to work out what was going on because at the time I viewed that as being so cutting edge. Like it's got to be, this is the solution to all AI problems, we just turn it into a genetic algorithm problem, and that'll definitely solve it. Luckily, a couple of years of computer science taught me that isn't exactly the case, and that brought me into the machine learning world. And so I've been studying pure data science for about a year now. And so I first started listening to the podcast because I desperately wanted to understand BERT, understand
Don't
the
we
whole
all?
concept of it. And I was doing an NLP project, and I decided that, oh great, I'm going to use BERT vectors for this problem. And at the time, I was training for a marathon, and when you train for a marathon, you have a lot of time running very slowly. And so I thought, let's merge these two things together. And I looked up a podcast, and there was Data Skeptic podcast. You had about 7 episodes, all on BERT, and I had a whale of a time there, and that brought me to the podcast.
Well, I'm so glad it did. Yeah. And I also appreciate that you had the interest in BERT, because it's one of the things we're most excited about sharing with listeners, not just in talking about it, but
Mm.
we have built a lot into Portal to work with it. I'm going to do a quick demo, but then maybe we can get into some of the ways you've used this tool I'm going to show. Just for a quick demo, here's a CSV I made as some fake comments from Kyle, Linda, and Yoshi. One of our options is to generate BERT vectors from this. So you upload your CSV, you say which column you want to get the BERT vectors from, and hit run. And out of that, we're going to produce you a second file. As soon as it's ready, it'll appear in the same folder. That's going to just append all of the BERT vectors. So Georgia, I don't know that anyone can easily sum this up, but for people who don't know what the heck we're talking about, what are these numbers I just computed?
Oh wow. So I guess a vectorization is just a representation of the sentence you're seeing.
Mhm.
And I guess, ooh.
So I should have prepped you for this one, put you on the spot, but you're on a good path. That's exactly
Yeah.
right. It's a representation.
And it's so a project that I'll talk about in a second. I tried to compare BERT vectors with TF-IDF vectors, which is a much simpler way of looking at things. And I feel like perhaps if I talk about the TF-IDF version, it'll be
Let's do it,
a good
yeah,
way
because I
to
think
ease in.
listeners will know a little bit about
Mm.
TF-IDF.
So that just looks at your entire corpus of documents and the current sentence that it's looking at, and it'll generate a score for each word based on its frequency within the corpus. So you can
Mhm.
think of a very infrequent word in the corpus, when it's used in the sentence, will have a very high score. So if you imagine, let's say on the podcast, someone mentioned pancakes, and that appeared in the transcript, but it's never appeared in any podcast that we've recorded before.
Mhm.
TF-IDF will score pancakes very highly. And so that then is put into our vector representation. But one of the flaws of TF-IDF is that it abandons sentence structure. So
Mhm.
it works off a bag of words model. So it effectively just looks at an array of words. It doesn't know anything about the order of the sentence. Whereas BERT is the vectors are generated in a bidirectional way. So it considers the tokens before and after.
Mhm. And yeah, so BERT has been a really powerful tool that's changed a lot in the natural language processing world overnight. I mean, we saw so many research papers go from, these like sentiment analysis of like, I don't know, 70% accuracy to suddenly everything's like human level or greater. Just a very powerful technology for a certain set of problems. Um, and it's as simple as this, really, for people who do some machine learning. If you apply a tool like ours here that'll compute the vert vectors, these as features, even though they're kind of numbers that have no clear meaning or representation to us, are immensely powerful for machine learning processes. So if you wanted to maybe predict who said a certain comment, that could have a high success rate. It's not one of the golden applications of BERT, but maybe. So when we were doing our transcription project, we're taking all the episodes, the current ones, and we're going to go back into the archives as we get more supporters and turn every episode of Data Skeptic and Journal Club into a text transcript. because that way it makes it searchable. People can find things, they can reference it better, stuff like that. So we are using an off-the-shelf transcription tool that works okay. But there's still a couple steps because it doesn't know who George, Lon, and I are when we do a Journal Club episode. So we've got to figure that out in some way. And I set that challenge to you, Georgia. And I specifically said, try and do this with natural language processing techniques. How'd it go?
Yeah, exactly. So yeah, this is a work in progress. So we've put in all the hooks for the transcription, so we can send one of Claudia's fantastic edited MP3 files. We send that off, and 5-10 minutes later, we get this JSON file transcript of the episode. And so, unfortunately, one of the easy things there would be to perhaps. So it gives us like speaker 0, speaker 1, speaker 2 for the people that it detects. And the thing that you would think is the obvious thing is that the first person to start talking would be speaker 0, but I found that is not the case. It's really rarely the case that the first person starts talking is speaker 0. The only pattern that I did see is Kyle, majority of the time is speaker 2, but then occasionally he's speaker 3. So it's in our small sample size, it's really all over the place. So unfortunately, we had to look for another solution to this problem. But then what we have is this transcript, and me, Lan, and Kyle, we have very different talking styles. We probably mention different things, have different frequencies in the terms of what we use, perhaps different localizations as well. My British English will be different from theirs, and so the one of the blog posts that actually I'll just share my screen quickly here.
Cool.
Because it might be, I've realized that I might be one of the few people who is both has both done development on Portal, but also been a user of Portal. Like this blog post I did entirely as a user. So I sort of wrote the functionality and then used it for another end outside of Portal. So here's a very simple sanitized environment. We have an audio file here, and then you can convert that into text, and then it gives a JSON file transcript. This is a huge file with a lot of redundant information in it. We then reshape the transcript into something that's a bit more reasonable to the eye. And in the reshaping process, we have the option to stick in our speaker mask, our identification for each of the speakers, and that is the ideal place to put this prediction model. And so what I did to use Portal as a user is I uploaded a bunch of Claudia's files. I think it was maybe 10 in total. I had one that I used as the test set, but 9 that I used as training data. I sent them all off individually to be transcribed, and then I pulled the JSONs out. And then I also, as Kyle has demonstrated there, I got the BERT vectors for them as well. And then this is just the blog post. I won't dive into the blog post because I think in 2 episodes time we'll have a rundown. There's a great discussion we did about this blog post. But I compared TF-IDF vectorization and the BERT vectorization. And I tried to use the scientific method as much as possible. So the architectures of the models, apart from the initial embeddings, are identical. In the case of BERT, I did have to train the model for a bit longer because it took a significantly more epochs in order to converge.
So good methods. I like the approach. The proof will be in the pudding if our data admits a nice solution or not.
Yeah, I would say that it's been a fun process, but perhaps not necessarily the best approach for this problem.
So are we, what sort of accuracy or metrics are you looking at for our text attempt?
Well, so the way I've set it up is that we generate a prediction for each sentence within the transcript. And what we know is that, or at least what we're relying on, is that the transcript is able to at least separate the speakers perfectly. So we have speaker 0, speaker 1, speaker 2, and we want to predict who is Kyle, who is George, who is Lan. And so what we can then do is generate a prediction for each individual sentence and then work off the average, which is pretty useful in our case, because actually we really don't need very high accuracy in order to be able to do that.
Yeah.
I guess it's sort of the law of averages.
Yeah, this has been an interesting and also frustrating problem, because there are certain aspects of it, like you would think, "Hi, my name is George" is a phrase hopefully only you are going to say on the show. And we kind of look for stuff like that. There's little gimmicky tricks, but I'm worried about text as our approach. Even as I read through some of the sentences as we discuss a paper, I can't myself with my eyes always say, did I say that or did George say it? What do you think? Are we on the right track with an NLP approach?
I think you could do it. I think you could do it with enough data. You could do it, but it's quite inefficient because just from a sort of theoretical standpoint, you're feeding something into a model and then feeding that into another model. So you're going to be picking up artifacts along the way. Like the task of detecting written text between the three of us, I think would be a much more trivial problem. But because the transcription service is I feel like the transcription has a voice to it. Perhaps this is me anthropomorphizing it, but the way that it writes down sentences is often similar between people, and the grammar of the sentences are always the same. Whereas, like perhaps I use more hyphens than you would in a sentence, something like that.
Sure, yeah.
And so by converting the audio file into text, we're losing something. I guess it's a lossy conversion there.
Yeah.
And so I think it probably would be best just to use the audio.
I think so too. We're going to have to go after that. So maybe we can get into that in the latter half of the show and talk about approaches for audio. But let's move things along and welcome Lan into the group. And we have the Journal Club panel assembled. Let's see if she's able to join us, get linked in. Hey, Lan.
Yeah,
Thanks for joining us. Well,
no problem.
People will hopefully already know you from listening to Journal Club, but in case they haven't checked us out yet, tell us a little bit about your background and how you got involved with the project.
Sure. So I was a neurophysiologist by training, and I did research in lab in universities before I became a data scientist. So right now I am a data scientist in a biotech company in Oregon. And I've been a long-time listener of Data Skeptic. A first time personally connected with Kyle at the PyData in LA. And I'm very happy to have the chance to be a panelist on the Journal Club show. And I've enjoyed it very much so far.
Well, it's been fabulous to have you, and you brought some excellent papers to our attention.
Thanks.
And shout out to PyData. I think they're going to be doing some events coming up remote. We'll cover it a little bit on the show or something, but I think August they're setting some dates. Should be a good event.
Awesome.
But anyway, yeah, Journal Club is our first, or I guess our second whole podcast panelist show. Really enjoy recording with you guys. We do, each of us brings an item and we go through them. I'm going to do the paper today, and I'll be covering, we can even do some visuals maybe. Interpretable and accurate fine-grained recognition via region grouping. That'll be at the top of the segment. George, why don't you tell us what you brought us from the news?
Yeah, so I'm covering an article from O'Reilly, which is it's about what to do when AI fails, how to handle a failure of an AI system.
Good choice. And how about you, Lan? What are you going to feature this week?
So I brought a news article titled AI Hype or AI Hope. When will AI disrupt the pharmaceutical industry?
Oh, hopefully soon. Let's start there. What'd you learn?
Yeah, I don't think this article gives us a concrete answer if you're really interested in the problem of the question of when, but it is a nice primer sort of describing why has it been so hard to really disrupt the pharmaceutical industry in a meaningful way. So it has to do with the drug development process being a very, very lengthy and costly and complicated one. So I have to, I should mention this article was appear in Forbes, but it's written by Alex Zavron. Sorry, let me say that again. Alex Zavonkov. Zavonkov, I think that's his last name. Oh my God, I'm already butchering his name, but sorry. This is the founder and CEO of In Silico Medicine, which is a company that's very much in the forefront of applying AI to the drug discovery industry. Yeah, so.
Quick footnote, I had the chance to interview him at NeurIPS a few years ago. So if you go back in the feed, I think it's in the natural language processing year, he and I got to chat.
Oh, that's super cool. Yeah. Yeah, I've had my eye on this company for a while, kind of follow their stuff. They publish a lot of papers and they do a lot of presentation in conferences. So yeah, it's pretty cool area to try to focus AI on nowadays. It's sort of still a holdout, if you want to call it that way. It hasn't been changed by the new technology in a very big way as some of the other field has. Yeah, so maybe we'll briefly go over like the whole process to develop a drug.
Let's do it, yeah.
As the backdrop of the problem. And so he mentioned in this article, it now costs over $2.6 billion to make a new drug and go to market with it. So that's a huge number. Not many organizations can invest that kind of money in a lump sum, right? And it usually takes on the scale of like 8 to 15 years to do that whole process. So why does it take so long? It's usually because you start with a disease that has a market need, like it needs a new treatment, or existing treatment really doesn't work so well, or it's too costly, something like that. And then you have to really develop first the biological and physiological understanding of this disease. And that's a immensely complicated problem right there. So you gotta understand all the biological targets, proteins or genes or pathways in the body that is involved in the disease. And that knowledge comes very incrementally through research and drug development. So you gotta go through all the literature to kind of generate that knowledge graph, that good understanding of the underlying mechanism of the disease. And that usually takes like anywhere up to 5 years. But AI has been used in this biological target identification step. I've seen papers, many papers in recent years that's targeting that step alone. So yeah, so that's the starting point. And once you have the biological target and kind of validated it through some research or testing in the lab, then you go into identify novel molecule, antibody, an inhibitor, whatever have you, to target this protein of interest. And that's another pretty lengthy process. Traditionally, it's done by experts that have knowledge about chemical structures and how chemical molecules will interact with biological, like proteins or genes of or RNA. So, but now AI has moved into this area in kind of a big way. People have used GANs, generative adversarial networks, and reinforcement learning in this area to try to design new molecules to target biological targets. I think I'm a little bit freezing. Is it okay? You guys can hear me?
Yeah, it's good.
Oh, cool.
I was going to say that, so you mentioned that there's that sort of one section that's been tackled by AI. Is there any room for other stages in the process to be?
Yeah, definitely. I think all stages can use some help from AI, or it's just a problem of coming up with meaningful advantage over existing technology, and that is also interpretable by experts and understandable by scientists, because eventually these are going to be developed into therapies. So we really need to know how they work or doesn't work. So it's not okay to say it's a black box, yeah. Yeah, but I thought it was kind of interesting that GANs and reinforcement learning has been used in the drug development pipeline, especially in the phase of designing new molecules and maybe even antibodies and stuff to target a specific protein. Yeah. And then after that, once you have a molecule or many molecule, a library of molecules, these are called leads. So then you need to validate them through some preliminary preclinical study, usually in cell lines or low-level model organisms, before you can actually get to clinical trials, which is usually performed with human subjects. That yeah. And it's a really long and highly regulated process, the clinical trial phase, which it should be. And then that eventually either fails or succeeded, which is a very low probability. I think something like 1 out of 100 drug molecules that get to the clinical phase actually become a marketed drug. So it's pretty risky process and costly as well. Yeah.
Yeah, I know this is a distraction sort of out of context from the main topic here, but from what I understand, there are some very troubling game theoretic implications of that. What is the motivation for investors to spend such huge sums of money on things that might not turn into anything? And then, of course, if they do, you want like patent protection, right? Like, this is only my drug and only I can sell it, and it's $1,000 a pill because it cost $1 billion to make, but no one wants to pay $1,000 a pill.
Yeah, that's a very good point. Yeah. Seems like no one can win in this situation. If you don't invest the money, you're not gonna bring the drugs to market. But if you invest the money, you gotta recoup your investment somehow. Yeah.
So I don't know what needs to change, but I think universally people acknowledge this as a bit of a problem. But AI can certainly do its part, as this article covers.
Yeah, exactly. So hopefully we'll see more application in all stages of this whole process. Yeah.
I'm especially excited about GANs.
Oh, cool. Yeah.
I mean, I don't have any deep insight into this, but just the method of you have one system generating ideas and one trying to discriminate the real from the fakes seems like a powerful approach to these problems that have befuddled a lot of people.
I think it's especially interesting they kind of combine GANs and reinforcement learning. Mm-hmm. So not only does the generator try to generate real looking molecules, but also the discriminator is able to assign some kind of fitness level to this generated molecule based on existing data that is embedded into its architecture and training. So it's rewarding molecules that are more that are generated, which has more drug-like properties or which has more selectivity or whatever metrics you can encode. So you can inference the next step the generator takes to add on to this train of molecules. So yeah, it's pretty interesting.
Yeah, thanks for bringing that. I'm very excited about research like that.
Cool. Yeah.
George, any reaction, or should we jump into AI doing things we don't want it to do?
Yeah, I can jump over.
Let's do it.
So this week I am talking about the article so the title is "What to Do When AI Fails," which is a very scary title. And my initial thought was it would be quite clickbaity, and so that was the reason that I picked it for this week. But actually, on investigating it and reading it, it's quite a thoughtful, considered bit of writing. So it's published by O'Reilly, who are they're a computer science textbook publisher. They're the ones who do the books with all the animals on the front.
Right.
And I
Yes.
think because of that, it has it's handled really well. I believe the authors Andrew Burt and Patrick Hall have written textbooks or written part textbooks for O'Reilly. So it's clearly written for this for a machine learning practicing audience, and hopefully not an audience who are frantically typing into Google, "My AI has failed. What should I do?" Hopefully, it's people looking ahead and thinking about what I can do. So one of the focuses of the article is it defines this thing or the concept of AI incidents, and there's this repository of they say at least 1,200. I haven't had a look into it, but they say 1,200 AI incidents that have been recorded about that you can go and read up and sort of learn about what's presumably long form papers that have been written on AI incidents. And actually, later on in the article, there's a call for people to write more and be more open and more public about when their systems do fail, because of course we can all learn from other people's mistakes, and instead of hiding them, perhaps it's for the benefit of everyone that we're quite public about these things.
Absolutely.
So there's this taxonomy they define. So there's like these two branching paths for these incidents. So they're quite plainly cut into internal and external incidents. So your external incidents are things like attacks. So we've looked at papers on adversarial attacks. So it's things like that. It's some malicious agent trying to manipulate your model and either take some data out of it or force it to predict something that you wouldn't want it to predict. And the other kind is like an internal failure. So something that goes wrong that isn't the fault of anyone else. That's either the fault of you not paying enough attention, or perhaps there's something wrong. There's something wrong with the data that goes into your model. So there's a really fantastic quote that is unfortunately it's hidden in a footnote. But the quote is, "Complex systems tend to drift towards unsafe conditions unless constant vigilance is maintained," which it's a great quote, but then it leads into sort of a definition of one of the internal failures being data drift, which is it's quite an obvious problem. So let's say you have a model that's trying to predict something, and it's based, all of your training data is, say, 2010 to 2020. And it works fine in 2021, 2022. But if you stop updating that with new data and you stop measuring the accuracy, data drift is the phenomenon where your prediction shifts because of some change in reality. Your model is now no longer predictive of reality.
Mm-hmm.
Mm-hmm.
So I personally have not made any AI models, any machine learning models that have put anything on the line. They've all been personal projects which have had absolutely zero stakes, not even low stakes. And so my takeaway from the article is that it's really interesting. It gives a lot of sort of best practices for what you can do, but because I'm unlikely to be in a senior position where I can actually like sort of change the policy of a company, I sort of fail to there's nothing in here that I'm reading and going, oh, I need to update how I do things because of this.
It's perhaps better if you read it before you reach a senior position, so you're more prepared.
Yeah, exactly. Like I think it's a good little, well, it's not a textbook, but like the publisher that it comes from, it's almost like a manifesto for someone who is going to be in a position where they can change policy. Even someone who is sort of starting a company, it would be a good thing to read this through. And if anything, the best practices are really quite simple. You can summarize them into just pay attention to your AI systems, monitor them, and make sure that you keep your security updated. But which I think would be the same for any software system. But you have to, of course, think that an AI system will have different challenges to it than a normal software system.
Yeah,
and often it will
exactly.
have far more complex challenges than an average
Sure.
software system because of the infinitesimal number of like moving parts that interact.
Yeah. One of the things we've had to face on the consulting side of Data Skeptic, where we help companies figure out how to do machine learning in the cloud and stuff like that, is there is often a big fear of actually updating their models because they've learned so much from the software world of like, don't touch it, don't break it. If it's working, leave it be. Don't do a release unless you have to. That philosophy doesn't work so well with models. I mean, in some cases maybe, but as you said, if there's drift, well, that model probably needs to be updated.
Yeah, so you have to monitor it in deployment to detect drift, right? Is that a tricky thing to do?
It all depends. I don't find drift to be hard if you're willing to invest in the infrastructure, because to me, the technique is simple. Build your model whenever you've got it, you're happy with it, put it live. Okay, fine. Do the same thing once a week or once a night or whatever the cadence is that's appropriate for your application. So now you have 2 models or N models over time. Maybe the first model is still what you use in production, but have these other ones there too and compare them all. And if they're all predicting the same thing, then you're pretty much good to go. But if the predictions start to evolve over time, that's a nice measurement that indeed you have drift.
So your N models retrain with different data? Is that how you're chunking the data streaming in, you're retraining with, or maybe fine tuning it, not retraining from scratch with a bunch of new data?
Yeah, in one particular application, it's a nightly batch process that runs and pulls the last 90 days out of a SQL database. So it's a rolling 90-day window.
Yeah.
So from day 1 to day 2, it can't drift very much, or if it is, that's a different problem. But after 90 days, yeah, even after like 45 days, we'll see that things are evolving.
But then once you've evolved, once you decided you should use a later model, then do you throw away your previous model, or you still keep them around? And maybe sometime you'll drift back.
Could be, yeah. So this is a very case-by-case thing in my mind. Like if I were working for a bank, I would have to save all of them because I would think maybe we're going to get audited of why did you make this choice on this day. In the application I'm thinking of, it's a lot simpler from the client's perspective, and there's very little harm done in just rolling to the new one because intuitively newer is better, and there isn't a lot of fear there. But yeah, certain cases, you don't know.
I guess it relies on you having access to ground truth data moving forward. So perhaps in a scenario where if you're making a prediction, you need to have the experts who made your original training data to do their job again and build you some test data so you can make sure something hasn't gone wrong.
Sometimes that's costly.
Yeah, exactly.
Definitely.
So the one thing that underpins the whole article, which I haven't mentioned, is interpretability. Like it's sort of all the way through. There's talk of transparency being important, and I didn't really consider like interpretability, of course, is really important to this, but it's sort of like it can be used as a preventative tool in the instance of AI failing, because you can interpret something and perhaps discover that your model is discriminating before it goes into production. But then there's also it can be used to sort of diagnose what problem did actually occur, because if something goes wrong, if you have a black box model, you won't really know what happens. And so interpretability tools can be used to sort of analyze and do a post-mortem of whatever happened.
Yeah, that's a good point.
Yeah, interpretability certainly plays a strong component in a lot of how do we have safe AI and explainable AI and these sorts of things. Good article. Any other comments before we move to our main paper?
I would say it's obvious the audience of this article because it references the George Box quote, the
Nice.
all models are wrong, but some are useful.
Some are useful.
Yeah.
Yes. I love it. I'm going to go ahead and share my screen so we can actually look at some of the visuals. This will probably air in its audio form as well, so I try not to rely on them too heavily, but let me do a quick Zoom share here. So again, the paper I'm going to cover interpretable and accurate fine-grained recognition via region grouping. So a lot of pieces to that. Let's break it down bit by bit. First and foremost, let's talk about the, well, obviously it's interpretable. So when it comes to deep learning models, the accusation that has been so appropriately leveraged against these models is that they're black boxes. We don't know what they're doing inside. It's these tensor calculations. We're not quite sure, even though we know how it mechanically works, we don't always understand why it arrived at the conclusion it arrived at. So there's a lot of different approaches we covered on Journal Club of how to make models more interpretable. And this follows along some of those themes, but gets innovative in a couple of ways, specifically related to this region grouping stuff. So one more thing before we get to that part of it. Accurate. One of the novel results in this paper is that their model, which has these interpretability features, seems to be pretty much on par with other models applied to the same data sets and problems for doing image recognition kind of tasks. Which is to say that this idea that there's a trade-off between interpretability and complexity, that you have to sacrifice interpretability for accuracy, this might be a false dichotomy. It seems to be the case that there are opportunities to build interpretable models, and this is one of many papers kind of bringing that banner forward. Fine-grained recognition. The fine-grained part, for those who don't know, is just about determining similar things different from each other. So here we see they're working off of the bird data set. Birds often, especially to human eyes, it's hard to tell the gender apart. And sometimes, I guess, visually you can't. You have to inspect them more anatomically. But depends on the species. Obviously, birds are quite diverse. And some, if your eye is well trained, you can notice male from female. And neural networks have gotten pretty good at that as well. Fine-grained is simply to say that it can tell a subtle difference like that, where there are class labels that are similar. Basketball and soccer ball are not similar, even though contextually they might seem similar, because they're visually very different. And region grouping. This is not a new idea from this paper, but it's a critical one that Huang and Li have put in here. Region grouping is where you try and divide up the image into kind of a mosaic, for lack of a better term. And each of those regions can then be thought of as if they were like features in sort of the very traditional plain vanilla machine learning feature engineering type approach. So as a first step, they want to look and say, how can we divide this up? Because not only does that produce some of these images like this that help us with interpretability, but they can also help the system regularize the training data as well. I'm going to skip to a later image that I like more that tells a little bit about their work. This one here, in which they're showing the method on the Celeb A data set. So the paper goes through 3 cool data sets that I like because there's some diversity. Celeb A I was familiar with. It's a bunch of celebrity pictures pulled from the internet. What's neat about it is that you'll see the same celebrity in multiple cases, different from like, you know, a typical collection of a lot of photos that you might use. The second is Cub 20 or Cub 200, which I'm so excited to have learned about from this paper. It's an all birds data set, so right up my alley. I'm going to have to get involved with that in some way. Maybe I can submit Yoshi's picture later. And then lastly, the iNaturalist data set, which is a collection, a broad collection. I think it's some citizen science stuff, if I'm not mistaken, of photos taken of mostly animals, flora, fauna, that kind of stuff, as a nice training set. So in this one, it's the Celeb A data set. Here is the input image for your reference. And then when it was picking out certain features, the heat map feature area that's being highlighted shows where basically, I don't know if that's precisely an attention map. Oh yeah, it is. This is their attention map they're building. So in saying, hey, there are narrow eyes here, it's highlighted exactly where you'd expect. I mean, I guess it looks kind of like clown makeup, but pretty close, pretty good. And an interesting one I liked was wearing necktie, where you see it's highlighted attention on 3 people that aren't in fact wearing neckties, but the novel intuition is this is where I'm looking to determine if a necktie is not there, which, you know, I can say no by looking here. I can't say no by looking at your hair. So a very
Yeah.
novel thing. From visual inspection, I thought these were pretty impressive. We look at
Yeah,
a fair
they
amount
were.
of these.
They were
Sometimes
very
it's like looking at,
specific.
yeah.
I
So
I think this image alone passes the sanity checks that I spoke about in a previous paper.
Yeah.
So the sanity checks were a list of ways you can check whether an interpretability tool is just what's the word? Not cognitive bias. Confirmation
yeah.
bias. Confirmation bias.
Yes.
So it was, the paper found that certain interpretability tools effectively worked like edge detectors. So they would return this map of edges of the input image. And so of course you're looking at this map and being like, oh yeah, so the edges there are clearly showing that the model is detecting a bird, when in fact it was just detecting edges. And this image here, if this comes out of the and yeah, so this image here proves that it passes that sanity check, because it's not simply detecting the edges. It is detecting the edges, but it's detecting specific edges around, say, the eyes, around the hair, around the necktie, instead of just being like, oh, here's the edges of a face, so it's a face.
This is detecting the area. This is much more impressive than a lot of the atlases or gradient-based interpretability, image recognition interpretability tools we've seen, right? This is really zoom in on the specific area that is related to the class label. And that really is because they had incorporated this region partitioning and this attention map in the training and in their model architecture. So it's not a post hoc thing.
That's right. Yeah. And we haven't yet touched on, although you're leading right into it, one of the key innovations they present in the paper that I think gives them that leg up is this use of a prior. And it's actually kind of a, normally when I start seeing Bayesian stuff, I got to sit down and do a lot of homework because the math gets hairy, but it's a pretty simple prior. It's just
it's
like
surprisingly
a
simple.
Yeah.
Yeah.
So it's beta distribution configured so you get kind of the U shape. So basically saying that as they pick out all of these regions, so things like in the bird case, even though it's not explicitly finding a region and saying this is a wing and this is a beak, because that's a very hard-coded way to look at it. These are all kind of fuzzy regions that the system has optimized into. But as you look at those, it kind of puts a probability on those. Do they belong here, yes or no? And because the U shape, you have kind of a high weighting on yes or no. And then they develop some relationships between those. So if you see a beak, one would expect to see a wing and maybe a bird's foot, although depending on angle, the bird's foot might not be there. So when they have these regions and notions of proximity in this prior, that seems to be the key innovation that gives them this leg up. From the model architecture point of view, it's actually fairly elegantly implemented. I was going to say simple, but that always sounds kind of negative, so I'm going to go with elegant. It's just, they start with ResNet as the base. So it's just a convolutional neural network, like, you know, thousands of other people have tried on this type of problem. And the change they make is all at the last layer. They replace the last layer with this architecture that has a couple components. One is the part segmentation, so figuring out how to divvy this up. The region feature extraction and attribution. So that's where it kind of figures out, oh, this is the wing, this is the beak, that kind of stuff. And also has some sort of linkage that I don't fully appreciate yet, that is kind of captured in what I was stumbling through about a big beak should have an eye and a wing and that kind of stuff. And then lastly, the attention-based classification, because with these attention weights in place and the regions defined, you really do get a pretty interpretable model. It says, I made my choice based on this specific cutout, and that cutout includes some that proximity prior information. And as I'd mentioned, the remains really high in accuracy. I don't know what this double line is for and why ResNet 100, their base, and then their version is out here separate from all of these exactly. But as you can see, we're within, you know, maybe if we throw out STN, all these are give or take a few percentage points apart. This is the range where personally I worry that some of the higher accuracies are just overfitting. So I don't want to necessarily celebrate the maximum value. So the fact that this approach is in line with most state-of-the-art approaches and is giving good results that seem nicely interpretable is very promising. Excited to see this.
Yeah, it's really cool.
So if I get it right, it's something, it's almost like an upside down version of attention in NLP, where the attention layer is not the very first layer, it comes typically after an RNN layer. So it's putting the attention layer right at the very end.
Yeah, it's sort of it's really there for reweighting. So they have all these regions, and the regions could even maybe have erroneous things, like maybe this image, it would have said something about the water or a pond, but the attention would hopefully have drawn it to the duck, so that reweighting would allow us to say, we think this is a duck, not an ocean or a lake or something like that.
It's kind of similar in that in NLP, the attention was there to help you for each word or each token. It's kind of helping or kind of like mapping out where else in the text you should be associating, or this one is most closely associated with, right? So these are, so they kind of distill their image down to parts, and the convolution filters are acting as features, and then they group those features into regions, which represent a cohesive part of the object. And then they were using attention to kind of sort of shift their weight around to see which ones are going to be more predictive of the label. It's kind of similar to the NLP cases, and it's consistent with my understanding of attention, is that it should be kind of helping you to interpret what the model is seeing and why it's making the decision it is, right?
Yeah. And it is fascinating how well the same toolbox works for computer vision and natural language processing. Cool. Well, yeah, you guys, any final thoughts on this paper? Ooh,
I
pretty
really
stuff.
like the move towards, so this is an example of a model being made, model architecture being made more interpretable instead of, so I found myself bringing papers which tend to be post hoc interpretability tools, which are of course useful, but there's something a little bit more, I don't want to say valuable, but there's, there's something, I think I find that this work seems to me to be more important, because it's trying to solve the problem instead of put a bandage over the problem.
Yeah, this is a regularizer. I mean, this is trying to penalize constraints you don't like. It's a real ML approach, not some post hoc thing. Yeah.
Yeah.
Well, good stuff. I look forward to seeing people citing this and where else the research goes. I mean, accuracy can't get too much better than that, but I think this is a smart idea that I'd like to see more stuff come in here. Maybe even some more Bayesian things happening. Who knows? Cool. Maybe to wrap up, kind of improving this, didn't warn you guys in advance, but we've been starting to invite on guest panelists. We've had a couple now. I want to give you, as I've told you guys before, you have the ticket if you want to invite somebody on, but maybe we should give out some challenges for listeners here. First to do X, first to do Y. If anybody wants to know the path to get a seat on the show. Any thoughts?
Well, for it. We should give out free t-shirt for the first one who invites a guest, or to be a listener who volunteers to be a guest.
No, we're done with volunteers. We took a volunteer already. They're coming up. Now you got to work for it. Now, like, I don't know if we have an essay contest or you write a song or something like that.
Oh, wow.
A song would be good. A song would be good.
Yeah, so that's mine. First person to write a song about Journal Club can just instantly be a panelist.
Well, it has to be a good song.
Fair enough. Yep. We'll let Claudia be the judge.
Maybe you should make an AI model to judge the songs.
Could be, yeah. Or to predict if the essay is of a caliber we're looking for.
Oh,
Well,
we
all
could
right,
put that one that George had. How much is your writing like Bert, right?
Oh, yeah.
Had
Yeah.
that one.
That was an interesting news article we covered.
Cool. Yeah.
Yeah. So the person who can most convincingly give us something that invites them on the show, but was written by Bert. If you can get Bert to invite you on the show, that'll be another one. So go play around with that one site that lets you interact.
I've used the Talk to Transformer website as a writing
That's the
prompt
one.
in the past.
Oh yeah.
Like often I'll find myself with writer's block trying to write something for just to start a paragraph. I'll type in the first line, just let it go. And then typically what I end up doing is being like, this is dreadful. But then in the this is dreadful, I've found something to change.
That's great.
That makes a lot of sense.
Mm.
Cool.
I've gotten some spooky results out of that site. One time I just said, what will it come up with for Data Skeptic? And it was like the transcript of an email that James Randi was writing to somebody. And James Randi, who, for those of you who don't know, is a very famous skeptical activist and magician. So like
Jeez.
the fact that it pulled that in and did something in his voice was really impressive.
Wow.
Bird is amazing. And the whole, GP2, the whole slew family of those transformer models. But anyway, thank you guys so much for joining me in this live version. I know it's more to it. You've had to perhaps get into a good place and all that. So thanks for making the extra effort. This was a lot of fun.
No problem.
It's
Yeah.
fun.
Thanks for having us on.
Thanks.
All right, you guys, we'll drop here and move on. We've got a couple other segments. We're going to do a little bit more in Portal and share a few things there. Let me see who I have coming up next. I believe it's Alex. So pull back my script up and see if he can join. There he is. Some of you guys may already know Alex from being on the main Data Skeptic feed last year, or you caught his talk at the Ideas Conference, or who knows what else. He's been one of the major contributors here for over a year now, and glad to get you on the live stream.
Thanks, Kyle. Yeah, happy to be on, and happy to talk a little bit about what we've been doing behind the scenes at Data Skeptic, and what we have planned for the future. And yeah.
Well, let's do
should I
bios
do
to
a little
kick off.
background
tell
bio?
us about yourself and how you got roped into this Data Skeptic operation.
Yeah, so I did a PhD in neuroscience at UCLA, and I knew kind of coming up at the end of it that I wanted to get into data science. And I told this anecdote, I think, when I went on the Data Skeptic podcast, just like, what was it, a year ago now?
Just
something
about,
like that. But I'll repeat it here because I think it's kind of fun. I was getting into data science and reading all the blog posts, listening to all the podcasts, including Data Skeptic. And then you put out a kind of a call for applications for a data analyst. And I said, what the heck, I'll send an application, see how it goes. And I got a reply from you, and we started talking. I think we met up at the Ideas Conference.
SoCal Data Science Conference,
Yeah. And that's where we got to talking about what we could do together. And I feel like we hit it off. And I've been working at Data Skeptic about almost a year and a half now. So yeah, it's been great. Why don't I talk a little bit about what I do, kind of my role at Data Skeptic. It's been evolving for sure over the last year and a half, but it's basically split between we've got our internal projects at Data Skeptic, which have been fun. Usually they start out with wouldn't it be crazy if we did this conversation with you? And then we have a few more conversations, and then we just go with the idea. That's one of the cool things I like about working at Data Skeptic, actually, is there's this kind of feeling of maybe improvisation is one word for it, spontaneity. I like the spontaneity that we have as part of our work environment. And then there's the external projects, if there's a good fit between what Data Skeptic does and a client is interested in doing, we'll take a project on there. And I've been helping out with that. That's been great too. I've been just having a lot of fun doing different work inside and outside of or with internal projects at Data Skeptic, and then external projects with Data Skeptic. A lot of it has been kind of revolving around this idea of deploying machine learning models, I would say. And that's kind of one of the things that I talked about last year was this kind of like serverless machine learning pipeline thing that we worked on together. That was fun. And we've done other projects since, like this portal project, which is really less of a project and more of like a whole platform. And so I'm excited to talk about, how the machine learning approaches that I've learned about like deploying models have kind of helped us improve the whole kind of portal experience that we're helping to build.
Yeah. So I think we need your help with the ML pipeline to get involved in this transcription process. So I'll run you through where we're at. We just finished that Journal Club episode. That'll get edited down in some way, although it went pretty smooth. It actually was smoother than usual.
I've been listening the whole time, and I think this live stuff, as difficult as it seems like it could be, has been going pretty smoothly in my opinion. And so kudos to the whole team, you especially, and Claudia for getting this going. Yeah.
So maybe there'll be a few edits from the audio version of that episode. Maybe there won't, but then what we've already pretty well got solved in the transcription pipeline is the automated transcription step. Give us the MP3 file, get the audio out. And as we were talking about earlier, we've got to figure out who's speaker 1, 2, and 3. And since it's the finalized audio, there isn't really a clear way to do it from the original files. Now, maybe we could hack some things together or look at the ordering or things, but it really seems like a broader approach with some audio machine learning could be the right way to do this, something that could really detect who's talking. What do you think our options are there?
Yeah, well, you and I are both have a love for things audio. And so when we started talking about Portal, we were kind of talking about how the back end would work. I remember maybe like, I don't know, a little less than a year ago. And one of the first things we were talking about were like, what can we do with audio? And I spent a little time looking into what we could do with audio. One of the first features we built out was this wave file, which is like a format for storing audio, to spectrogram kind of features. And maybe I'll start sharing my screen now.
Let's do it.
Okay.
I'll be shamelessly self-promotional while we get that going. Just a reminder to people, sign up for our membership if you want to support Data Skeptic. If you can, it's tough times, but for those of you who want to, Portal is one of the benefits you're going to get. So this functionality, Alex, we got your whole screen. That's fine by me, but just an FYI.
Whoops. Yeah. Let me, I screwed that up. Sorry.
No worries. Just that Bank of America tab. That's the only problem.
Yeah, right.
Oh, perfect. These features we're about to show people, anybody who signs up to be a Data Skeptic member and support the podcast gets access to Portal, and that actually also gets them access to a lot of these tools, including the one that we're going to show that does spectrogram analysis. Let's see. You're having an audio issue. Can you share the folder to me? I can probably run it from my end.
Yeah. Can you check out a user folder that I might have shared with you before?
Here, I'll set it to my screen. I'll jump to it. All right. I don't know if I'm live yet. I'll wait for maybe a confirmation from Claudia. But yeah, we got to get a spectrum. We're good? All right. Yep. All right, we're going to share my screen. And then, I don't know if I clicked the box to share the audio. I think I screwed that up. Give me 1 second to fix it. Zoom has, in their wisdom, decided to make this itty bitty checkbox in the corner, share computer sound, which intelligently defaults to off. It should be off, but I wanted it on. So here we are. Alex shared with me. I don't know if this is the one or not.
Let's take a look. Yeah.
No, that's an empty folder. Sample model training. Nope, that's a secret. Are you able to share the folder again with me?
Yeah, let me do that.
Let me go in through the members area while I wait for that share to come in. We'll talk about a few other things people get. Let's do some bonuses. So one of the neat bonuses we have in here, as we've worked on this, these are misclassifications of audio samples. So members who want to play around with this, log into your members section. You'll get to come in here and I'll play a few. We're skipping ahead a little bit, but the ML process that we're going to show ends up trying to predict who's speaking and makes some errors. And it's kind of fun to see when it makes these mistakes. So these are false negatives. These are audio clips that were identified as Kyle, but are not in fact Kyle. So if I play these, you should hear them. Excellent. Well, all that.
Oh yeah, this was fun.
They've
I'll
got to
be
be
able to talk a little bit more about this when we get to the
interesting. Yeah.
machine learning part.
Let's play the last one here. Yeah. Yeah. So this is an interesting one. I hope everyone's hearing it. So you chop these up into 1 second segments, which is great for little bits of training data. This one in particular is tough. Let's just listen. Yeah. Yeah. There's laughter and a couple of voices. I'm not surprised that that would be a false negative. What do you think? The false positives? Oh, model unsure. That's
yeah. So I can talk a little bit about what happened here. So what the model ended up doing was it made these false negative mistakes, but when I was classifying your voice, it never made a false positive mistake. So it never said. So I was using audio from the Journal Club, and I had data from George's voice, from your voice, and from Lon's voice. And when I, during this set of experiments, it never said that George was you, and it never said that Lon was you. So, I mean, that for kind of a speaker verification model, I see some advantages there, right? Because if we're using it to, for example, verify that that you're an authorized user, some kind of authorization with this model, then it seems like a good idea for it to err on the side of false negatives rather than false positives, and mistakenly give access to somebody that shouldn't have it.
Yeah, let's listen to this one. The model unsure.
Oh yeah, no, I see.
I mean, that's George to my ears.
Oh yeah, no, I see.
No doubt about that. So pretty good model overall, despite we cherry picked out the errors. What sort of metrics are you seeing both in testing and in training?
Yeah, so, well, to be honest, training was like about 100% accuracy. So there might have been some overfitting going on. But even with the training and validation, the model was getting 99%. The testing and validation, the model was getting 99% accuracy. So what it's using is something pretty similar to the features that we're looking at right now, which is a spectrogram that's based on Fourier fast transforms of basically little windows of audio.
And the clip we were listening to just now, this is it visualized as a spectrogram.
Right. And yeah, so that's like one of the very first features that we wanted to build out for fees, which is the back end of the whole portal system. And so now we've got it, and we can see, what does the spectrogram for George look like? What does the spectrogram for Kyle look like? And for Lon? And, with these spectrograms, what they're showing is the kind of distribution of frequencies at in a given time frame for the audio. And so someone like Lon, a woman like Lon would on average have a like more high frequencies in her voice spectrogram versus you and George. So that is kind of like a high level idea of how we could use frequencies to discriminate between the speakers, right? But getting, discriminating between you and George, it gets a little harder to specify in English what the exact differences would be in terms of your frequency profiles, right? So I think, yeah, go ahead.
Let's get a little nitty gritty about the ML fundamentals of this, I guess. We're looking at the images, which are really neat. And I'm sure many people watching will think, oh, you've just converted this from an audio problem to an image detection problem, which is one option. We could go that way.
Yeah.
And sort of we do, essentially. But also, in addition to providing you the image, because portal users can convert any WAV file into a spectrogram, we also provide you with the raw JSON data. So if you wanted to export this and use this as a training data for a machine learning algorithm, essentially these long columns that I'm going to minimize are all that frequency data, and they make pretty good features. If these are your features and the objective label you want to predict is the speaker's name, that's more or less the ML setup, although it glosses over the implementation. That's the input and the output, at least.
Yeah. So what you're looking at there with the JSON file is basically all the decibels for the different frequencies that the fast Fourier transform is outputting. And yeah, so
Now,
that's a
this
basis for
visually,
machine learning.
this does not look like my voice to my eyes. Maybe I haven't trained them well enough for that. I want to understand the spectrum.
I couldn't tell you off the top of my head, but I'll take your word for it. I bet you've stared at a lot of waveforms at this point, doing all the audio editing that you did with Data Skeptic.
Oh, here's your share. Okay, I got it.
Okay,
this
cool.
will help people. Now, I really like this demo you made. Let's listen to this first. Tell us what we're about to hear. I have
Yeah. So something that I don't know if I've shared on any of the like podcast things that I've done with you so far is that I play instruments. I play bass. I love bass. I play other string instruments too, not as well, like the mandolin that we're about to listen to. And this is just me playing the note C on a mandolin.
Here we've got the E.
Yeah, E. And I'm also playing it. And
and then let's listen to the merged one just for fun. These are all three that we've merged into one now. Okay, and we've got spectrograms ready to go for each of them. So let's check out this one first. Now, this is data that's more agreeable to my eyes. I feel like I could learn to read this pretty quick, right? How come this looks simple and our voices look complex?
Yeah, like some fundamental frequencies, right? And then some harmonics on top. If you know a thing or two about musical notes, you might be able to pick out what the harmonics are. And it's a little bit cleaner, yeah, than a human voice. Agreed.
If we get enough signups, we're going to add a y-axis that tells you the frequency and continue to iterate and make this a fun way to explore stuff. Let's look at the E now. Keep this in your minds, and maybe we can do a quick jump and your eyes can visually notice the difference. Aha, the E, different spots. So these the overtone series is present here. Would be no surprise to me that you could develop an E detector.
Right.
And let's jump all the way to the merged spectrogram, all three of them.
Yeah, I think that's
Aha, so here we've got some complexity.
Yeah, and you can even see some jitter in my playing too, right? I'm not exactly playing strictly on time here, it looks like, but yeah, I don't know what the dots are. The little dots might be,
could be
I'll have to look into that. Yeah, it could be some kind of artifact happening when I make the PNG. I'm not sure. I'd have to look into that.
I was actually asking about the bars because I think this is one of the most striking visuals. These literally are, one-to-one, almost like the piano roll mapping. That is probably the E string here being played, and you can see it tempers off, and then you strike it again.
Well, these are, so they use fast Fourier transform for the spectrogram, but then they do like a slight variation on that called a MEL spectrogram. And I actually couldn't tell you the exact transformation it's doing there, but the end result is something that looks more like a piano roll. So that's kind of why we're using it, is because it's just a little more pleasing to the human eye than without the transformation. So
yeah. So this is our feature engineering process, essentially. Do we do anything on top of that, or does the neural network take it from there?
Yeah, pretty much the neural network. So it's pretty much the neural network after that. I mean, what we do on top of that is basically use a library that has been really great to work with called Ludwig out of the Uber AI labs. And that's doing a lot of the kind of data munging to help us get the data in a standard format to run some deep neural network training algorithms and start making predictions and improving and iterating on those predictions to give us a neural network model to begin predicting speakers.
Very neat. So we've got a model. You've trained a model sufficient for our needs. We can kind of set the text approach.
I don't
to
know.
the side.
Maybe I need to share that with you too. Let me look at that.
Oh, sure. Oh, yeah, we could go into it here if you'd like, but maybe we'll save that for a future video because we're running a little long and it is a upcoming feature. Users of Portal right now can get in here and do all the spectrogram stuff. Alex, I'm going to have you back later and we'll go over the ML pipeline when we release that so users can see how we build models and whatnot.
Yeah, sure.
I know we were going to do it. Sorry to take it away, but I think we're running a little long and I wanted to really make sure we hammer home where we're going with this transcription stuff. So you've solved the big problem that text analysis couldn't solve for us. You're able to detect which speaker is whom. Where do we go next with that? Who are we going to hand this off to?
Yeah, well, the newest member of our Data Skeptic team, Sophia, has been hard at work with, turning this into a full-fledged product. So I think maybe we'll bring her on shortly to start talking about how we make this a product and how we make it something that Data Skeptic listeners and members would want to use for playing audio with. So yeah, why don't I sign off for now and we can bring her on. Is that the plan?
Let's do it. Yeah.
Okay.
Thanks again for joining, Alex. This was great.
Yeah, sure. My
the
pleasure.
Mandolin stuff too.
Yeah. All right. I'll see you, Kyle.
Thanks for joining. All right. Hey, Sophia.
Hey, Kyle.
Welcome to the live stream.
Welcome. And I am welcome from Fraser's apartment because I like Zoom backgrounds.
Very cool. So why don't you introduce yourself? Tell the
Sure.
people a little bit about you and how you came to be on the Data Skeptic team.
Okay. Hi, everyone. I'm Sophia. I am the most recent member. I just joined in January and have been learning a ton. My background is in math and physics. I did math at UChicago, a lot of essentially 4 years of proofs, a lot of topology and solid state were two specialties of mine. I got into data science by accident, actually. I got a job working for a poli-sci professor in my last year of undergrad through a friend of mine because I knew math, so I should be able to do analysis of numbers apparently.
Fair enough.
And fell in love with it and have been doing that since. I also taught math for a bit and did some test prep and found you guys, and it's been great since I joined in January. I hit the ground running and have done a lot of stuff with Portal and with one other project we worked on internally.
Absolutely. Let's do some Portal stuff, actually.
Sure.
Alex, I think you heard, has really nailed it on the speaker detection audio thing. We now have a trained network that's in our ML pipeline, so you can hit the API anytime you want and send it a WAV file and say who is speaking.
Yep.
That's fun and that's great. How are we going to make use of that?
There's a couple different ways to do that. We have done some reshaping of transcription files from Journal Club episodes so that you can turn those JSON transcriptions into something that's actually readable so that it looks more like a TV or movie script where it has a name and then who's talking and what they say. That's one way we've done it. We also have the little image thing we did with the player with the time series JSON.
Pull that up. That'll
of
be a
course.
fun preview thing to show.
Definitely. Let me make sure the screen share works.
So we've got a couple of ways in which we're going to use the ML pipeline, but it's really fun that we can use our own show and share it with people.
Mm-hmm.
Couldn't share with you something that we're doing with a client, but here we've got a neat thing that Sophia's developed, kind of leveraging the technology Alex was talking about. So tell us what we're seeing here.
Yeah, so this is a page in Portal where you can make your own audio player. You can add in your own sort of playlist, so your own audio file, and then a special transcription JSON that we designed. And it gives you output. It outputs a script tag, so you can put that on any page. and then you could play an episode and the photo changes depending upon who is talking.
Boy, I'm long-winded. Come on, move it along. There we go. Hey, Lam. We got to see George in a second.
Mm-hmm.
I'm glad you muted. We don't need to hear this part, but very neat. So how does the player, there's George, how does the player get the data?
It gets the data from the output of AWS's transcription service. It gives you sort of the offset time, so it tells you the time when each person starts talking, essentially. And you just turn that, you just do a little Python magic and turn that into a JSON that this tool can read.
So you spit out a JSON. Could you bring us up a copy of that? I think it might be fun to look at.
Yeah, definitely. Let me find a copy.
Because the
quick.
interesting side of this, and we have to give a big
Yeah.
shout out to Corey, who isn't joining us today,
Yeah.
but he is a integral and critical member of the Data Skeptic team who has put together a lot of Portal, as well as that player you saw there. So
Yeah.
what's kind of interesting is that he comes from a very strong software engineering background. You come from a data background, and the exchange, the level at which you guys collaborate is really in the delivery of this JSON file, this format everybody's familiar with and likes. So you're able to do all this kind of neat analysis in Python, spit that out, and he can run with it in Node.
Yep. Yeah, I think I'm gonna turn off my screen real
Sure.
quick, because I don't think my Wi-Fi, I don't think it's good enough to open a new tab and screen share at the same time.
Fair enough. We've had good luck so far.
I know. Had to jinx it. There we go. Oh, I think I have Charter, and it's not the best here. Let me find a good example of one. I have like so many of them, actually. Here's one in here. I also have too many folders.
Well, while we're pulling that up, maybe it'd be fun to talk over some of the other features, because you've worked on a lot in Portal, from our NLP stuff to our computer vision. What's been the most fun or maybe most useful feature you've had personally been able to add?
I think so useful, doing a lot of doing the audio stuff this past couple weeks with FFmpeg has been really useful and interesting, like learning how to concat and merge audio files. You heard the merge file that Alex played earlier.
Yeah. We had his, to remind people, we played the C, E, and G, those separated files that he did individually, and then we used your merge tool to just put them into one.
Yep. Anything involving any of the like transcription tools or summary, the NER stuff that we did, building in both Spacies and AWS's Comprehend engine were both interesting.
Very neat.
Yeah, I just got to this page too, but awesome, you beat me.
Okay, so my screen's up then, cool.
Yep.
Yes, so this is your output. This is your deliverable, where at each offset, we tell it some field we're gonna change, and then what we're changing it to, and we're off to the races.
Yep, that's.
So what's neat about it too then is that all of the hard compute is done on the server, and it spits out this pretty simple file that, so no user is who goes to use our player is gonna have to expend their CPU doing some model in real time. We've materialized it into this.
Definitely.
And then here's a couple other assets. Oh, here's the transcribed one. Let's take a look.
Don't open that. It's gonna be a mess. It's huge.
Too big?
Yeah.
All right.
You can try, but it's gonna be like 20,000 lines.
Fair enough. Let me hit a hard refresh here, because I want to show some of the keyword analysis stuff you've also worked on. But overall, I guess let's talk more about where we're going with this podcast stuff. We've got everything transcribed. We've got this fun player. We're going to make everything searchable. Can we take on the world? What else can we do with these tools?
I mean, we are working on doing more name entity recognition tools with the transcriptions. So that's something that's interesting. Another thing we can work on is the transcriptions themselves aren't perfect. It's only as good as Amazon's tool is. And so there are ways to create vocabularies within AWS to improve the output of AWS's transcription service. So you can input terms and then the IPA pronunciation, and you can have AWS learn those words, which is kind of cool. I was just reading about that earlier today, actually.
Oh, very neat. We're going to definitely need to get into that, because our transcripts are not perfect. But despite that, here's another feature we ran on the transcript just to see the kind of topics.
Mhm.
This is pretty well aligned with things we go over. A lot of false positives, but oh, we mentioned Julia Evans, who was a guest recently on Data Skeptic. Very cool.
Mhm.
So she's in, what does she identify as? An entity?
I think she's a person.
Well
Yep.
done. Yeah,
Yeah.
I tend to agree. All right. Now we're going to do an experimental part of the show. I'm going to try and run inside and see if I can join Linda and Yoshi to wind this whole thing up. If the Wi-Fi gods do not allow that, Sophia, can you run the credits? I think you've got a plan for that, yeah?
Yeah, I do. I
Are
definitely
you
do.
able to share with audio to do that?
We can find out in a second if I can.
All right.
Let me just do this real quick.
Well, here goes
And-
nothing.
Sure.
I'm also going to switch audio, so this might kill me, but hopefully you'll get to meet Linda and Yoshi. All right, let's run with it. Run with it.
I found share computer sound. Oh no.
You lose me?
Okay. You hear me? Let's see if this works.
I do. Maybe I've been muted though. All right.
Oh no, it won't let me do this. Can you hear? Can you hear?
Girl.
Oh, shit. It's working.
All right, we ran the credits.
Mhm.
So I hope everybody heard that.
Didn't
I'm not
hear
sure
it?
if
Oh,
came
man.
through. No. All right. Let's exit out of this, guys. Let's move along, okay?
Okay.
Would you mind, Sophia, dropping the share?
Yep. Okay.
All
I just
right.
dropped it.
Can you guys see us now?
Mhm.
Or I'll make it so you can see us. I'm going to do a fun feature we have on Portal where you can take a photo right in the system. Okay, here's us.
Yoshi.
We'll get to Yoshi in a minute. Say hi, Linda.
Hi.
All right, watch what we're going to do, Linda. This is another cool Portal feature. Smile. So that's us. LTKP. That's one way you can get data into Portal. Let's view it. Make sure it meets your approval, Linda. Good photo?
Sure.
No, terrible photo, but let's run with it. Let's do facial detection and see what we get back. Yoshi, she's being awfully quiet. I don't know if listeners all know about Yoshi. We talk about her on the show, but maybe not as often as we should. She's our lilac-crowned Amazon. She's a beautiful bird who sometimes is quite vocal. Oh, like that. Oh, there we are. Detected our faces. Now let's take a look at Yoshi for our last Portal magic trick of the day. Here's our beautiful bird, Yoshi. Let's take a more glamorous shot, shall we? Let's come along here. That's good lighting. That good? Hi, Yoshi. Oh, you're such a beautiful bird. All right, now the real trick. Earlier, Linda, we talked about fine-grained object detection. How fine-grained do you think our computer vision is going to be at detecting Yoshi?
We'll see. This is the gamble.
Yeah, on a live broadcast too. All right, there's our Yoshi. Let's do computer vision, object detection. It's an animal, I agree. A bird, a parrot. Hey, not a parakeet. Not a person, although in the eyes of the law, maybe.
Definitely think she's person-like.
Not a macaw, although at low confidence. So not too bad, right? What do you think?
Yeah, you know,
Room for improvement?
yeah. I mean, Yoshi's a little bit more than that. Lilac crowned Amazon. She's definitely not an African gray.
Not an African gray or a cockatoo. So we've got some work to do, but still pretty nice for $5, right? You get all this stuff
Yes.
and support the show.
I am blown away.
All right, Lynn, do you want to stick around with me for the Q&A?
I think you should take it away. You're the best.
All right, I'm gonna do the Q&A on the couch in case Yoshi will fly to me. Claudia, are you gonna pull up Q&A? Oh, here she comes. Hey, everybody. So we asked listeners on Slack, I don't think we hit you up on Twitter, and maybe one other place, to submit questions about the show or about data science in general. And I'm going to stop sharing, right? All right, question time. If you wouldn't mind, yeah. Oh, yeah, if you would, please join me, Claudia, and let's do the Q&A that way. Awesome.
Cool.
Oh, I've got the first one here. I can get us kicked off. Why are real-time machine vision models so slow when ran through a browser, and how can we fix this? And this comes from, can you pull up the thing, or is it up?
It's up.
This comes from Zeka over at the Positive. Sorry, I don't know how to say that yet, but I'm listening to a show about investing. You guys should check that out on all the podcast places if you're interested. So why are real-time machine vision models so slow when ran through a browser? Well, partially because your browser, despite all the miracles of JavaScript, is not really a fast compute engine. I don't know that you get access to the GPU there. You could certainly do inference in the browser, but you're fighting a lot of different things from the TCP/IP stack and latency. I think it's just sort of an unideal way to do stuff. So I imagine new technologies, maybe WebGL and stuff like that, will be ways to improve it. There's discussion of edge compute kind of approaches. But yeah, you hit on a real key issue. Computer vision in Portal is easy. We just uploaded those photos and then I converted them. No harm in that. If I were to try and do a live stream of maybe Yoshi and do something like YOLO, which if you guys don't know YOLO, Google YOLO and YOLO 2, which are these impressively fast real-time object detection systems. But they do kind of the general classes, and I believe you can train those to be a little better. So not in your browser, but that's your best option I'm aware of for real-time stuff. So I think fixing it is maybe going to be a technology end type of thing. All right. What else have we got?
Okay, we got what are the techniques out there for model interpretability for deep learning based approaches on text data? The artists from the Artists of Data Science podcast community.
Oh yeah, I was recently on the Artists of Data Science. So thanks to Harpreet, and check out that. I'm either the most recent or second to most recent. Either way, just subscribe and listen. It's a pretty cool show. Sorry, I lost the question. Oh, what are the techniques for text? Well, we've covered a couple on Journal Club. I don't know that there's a standard just yet. Lime, the Python Lime library that we talked about a few years ago on the main show, is a good option. It has some kind of like attention weighting. I'm not sure if it uses attention, but it has a way of kind of doing either attention or something like it. And there are other saliency and attention map approaches, but that's very much at the cutting edge of NLP. It's a little bit confounded by the success of things like BERT, I think, because the vectors are so effective, it's hard to always know exactly how to interpret what they're doing. But more and more, these attention maps, I think, are going to be the way to go in text understanding, possibly also systems that can be a little bit more explanatory. So you ask like a Q&A system, you could say, and who is the main character of this article? It could say, well, this person is, and say a little bit more in the same way a student would write a few more lines in an essay. And perhaps that'll be a true strength of interpretability in NLP. Time will tell, I guess. We'll see where research goes.
Awesome. And then we got our next question, also from the Artists of Data Science podcast community. We have, how would industries that are regulated, such as banking and insurance, which highly value interpretability, make sense of output from pre-trained models?
Ooh, that's a good question. That pre-trained model is at risk of having a bunch of stuff in it that you don't necessarily know about. When they're trained on these massive corpora, they can often embed a lot of information. I could definitely see a bank being concerned about that. In the worst case scenario, I'm afraid that bank might have to build their own pre-training from scratch and be able to say that, you know, the home office certifies this model that's at this S3 location because we built it. But interpretability tools might be the answer. Maybe if there are things that are convincing to people, they'll let go of this idea that like, hey, we don't know where that pre-trained information came from or who knows what's in there. I could definitely see where I wouldn't want, if I was at a bank, an automatic email being written, or maybe be concerned about what a chatbot would say to a person. But some sort of combination of, oversight and typical ML techniques. I don't think this is new. Banks have always been looking at, should we or shouldn't we apply ML? Um, I'd like to think there could be open source components to it because I'm a strong believer that if you want to put out a black box model, but releasing it for people to research and investigate, add some tools and some options. But definitely a good question in that this is a major area of interest. Ultimately, it comes down to the decisions being made. So the bank needs to track what did it decide and be able to convince itself that that decision was both in line with regulations and the mission statement of the company, I guess. So if interpretability can do that for you, I think that's the way to go.
Cool. So now we have our next question from Harpreet Sahata of the Artists of Data Science podcast. I might have butchered that name. But the question is, Spotify has all of your listening data, and if you're someone who is usually listening to upbeat and inspirational music, what intervention would they do, or should they do, if all of a sudden the algorithms notice that you're starting to listen to darker music?
Ooh, interesting. So I think the implication is underlying implications that maybe there's some sort of like psychology thing to do there. If we're just talking about music recommendations, which I kind of feel like that's pretty innocuous. I don't think you could put a court case up and sue somebody because their music made you sad and you didn't follow through on your job application or something like that. I'm a little skeptical of any sort of blame for listening to music, but it doesn't have to be that they're going to get sued. It could just be that you've listened to this happy, upbeat music. Now you've started listening to this darker music. Is that your preference, or do they want to nudge you in one direction? And that I could only answer with experimental results. I would want to A/B test some approaches because if your tastes are evolving, who am I to regress them to what they were? But if you're just dabbling and you want to mostly have that recommender system sample from your typical play pool, there's an argument there. So a lot of these cases, and I haven't done a whole lot with recommender systems myself, but I've always found that there's a lot of access to ground truth, but only in production. So you've got to kind of release these models, play with them, see how they go, and be ready to try something else, multi-arm bandit, or switch things around. But I don't personally think Spotify has any duty as far as the tone of things goes. I maybe they want to give more interpretability in their results and say like, hey, you can control the randomness or control the random walk aspects of it. I don't know that it does that. Maybe that'd be the way to go if Spotify really wanted to do more in that area, I think.
Cool. Okay, so our next question is, let's see, it's also from Harpreet Sahato of the Artists of the Data Science podcast. So sorry if I'm butchering that. But, okay, so here's the question. What's the process for feature engineering with audio data? How would we isolate speech from background music and background noise? What are some of the best practices for creating features from raw data, and what are some good places to start for creative baseline models and selecting metrics to optimize for these problems?
Ooh, good question. And this is serendipitous because it would start with some of the work Alex and I were showing earlier. Audio data comes, we're used to seeing like the regular amplitudes, the waveforms. That's just volumetric data and a little bit of timbre data. When you run the fast Fourier transformation, get the frequency data, that's now something that contains a lot of information about music. So, for example, separating music from speech. For one thing, you want to know the pitch, and instruments tend to play very much on pitch. I mean, yeah, like trombones can slide and violins can do some stuff, and certain rare instruments play like half notes or semitones or whatever. But for the most part, instruments are playing the notes of the scale, and if it's tuned, that's a little indicator. So My voice, I'm not speaking at one particular note. I'm all over the place, mixed in with the music. So if you just cut the 440 band where the note A is, you could take out all the A's, but you'd also damage my voice. So I think a machine learning process is appropriate there. Best case scenario, you have isolation. So play the music alone, the voice alone, and then the mix, and then ask like a seek to seek model to take a fully mixed track. And the prediction it wants to make is, what does this sound like without the music? Or was it sound like without the voice? Either way. So that's how I would frame it as an ML problem. And I think you'd have pretty good success on that. I don't know that any information is destroyed when things are merged. I think the frequency information might be pretty clean. And if not, modern deep learning techniques could fill in the blanks. So hopefully we can experiment with that. That's a good idea. Thanks for the question.
Cool. So our next question is from Joanna F. from San Francisco. What will be the next theme of the show after interpretability?
Ooh, fun question. So yeah, last couple years, Data Skeptic runs on a theme, and right now we're in our big interpretability theme. I don't want to announce it. We want to do a little countdown and tell members first and stuff like that. But I will say, August, we're going to switch over. So interpretability is going to last a few more months. And then we have a one-word topic to carry us out the rest of the year.
Exciting. So
Stay tuned.
our next question is from Ron F. from Austin, Texas. And
Okay, no, Ron.
he said, you mentioned working in market research during an interview. What do you think about IAB podcast standards?
Ooh, this is a can of worms. So here's what I know. We get our stats through a third-party provider. The only reason I don't fully host the podcast myself, we at this point built all the technology to do RSS and stuff in-house. I only use a third party anymore because I want their stats as like a validation. You know, like, hey, I went through this company. They're a big company. They're not going to play games with the numbers. Like maybe my software, someone could accuse me of overcounting or something. I'm using that company's numbers for the official stuff. IAB came around. That's the Internet Advertising Bureau. They're the people who have, like, define the standards of what a banner ad size should be and stuff like that. They have come up with some standards about podcasts and counting them. There can be issues for what does it mean, like what do you count with podcasts? Listeners, subscribers, downloads. Ultimately, all you can count is downloads, because at the end of the day, a podcast is just an RSS feed, which is just a set of links to audio files that some software you use is going to download for you, your podcatcher or iTunes or whatever that is. So, you know, if I want to bump up our stats artificially, I could just download that file a million times. So of course you filter by IP and different stuff like that. And IAB has tried to come up with some standard for doing all that. Certainly that's well-intentioned and something like that's needed. I have heard rumblings in the community that it is over-filtering and that people think it's too aggressive. Yet I don't have an opinion on that. If it applies globally, then we're all getting conservative numbers, so maybe that's okay.
Cool. And then our last question is from John from the US. Is there a complete list of all the things that Portal does for a basic membership?
Soon there will be. Right now, it's a discovery thing. Think of it like Minecraft. All right, just sign up, get your account, and start playing. Upload some files, see what happens. There's going to be a ton more videos going up and content we're going to produce, and maybe some more live streams and stuff like that. So stay tuned. We're adding stuff literally all the time. At the moment, it's a lot of show up soon. So more to come, and we will have an official features list.
Awesome. And then that was our last question for today.
Well, that's it then. Hey, Sophia, if you're still there, share that credits thing to me. This is our big finish. We're going to try and do just a fun way to wind up the show. We'll see if Portal can do the credits for us. Oh, yes. Thank you. She is. Do you have the link handy? Can we put it up? Yoshi the bird here you see me with. Awesome. She's on Instagram, and she's actually pretty super popular in the bird community. So that's cool. And you can follow her if you want. I don't really do the Instagrams, but I appreciate when Linda shares stuff to me. I'm looking for our credits. Oh, yes. And for Portal, let's just type it in. It's Portal/members. That's the link to use. Okay, page where you can sign up. You can support Data Skeptic. Our special right now, $5 a month gets you in. You support the show, you get 2 podcasts a week, and everything else we do. You get the exclusive members folder with all these bonuses and fun stuff. And best of all, you get access to Portal. Here's Sophia's data. Thank you, credits. Perfect. With all these fun features, I'm going to share my screen and make sure I share my audio. And let's cross our fingers that this works. I'm going to delete it, the pre-baked version, and show you how this is done. So here are our credits. I should have put Corey in here, even though he didn't get to make it because he's such an important guy to the process. And text to speech. We give you 2 options from our provider here. We might add some more there. And let's see what happens. Okay, Joanna, take us out.
Thanks for watching the first Data Skeptic live stream.
It's not working?
In order of appearance, our staff include Linda Tran, and last but not least, Yoshi the Parrot. This is...
Oh, sorry, I cut it off. This has been a Data Skeptic production. That went through okay? All right, play it one more time and we'll call it a day. Thanks everybody for watching.
Thanks for watching the first Data Skeptic live stream. In order of appearance, our staff includes Kyle Pulich, Claudia Armbruster, Vanessa Busiaga, George Kemp, Len Guo, Alex Reeves, Sophia Alice, Linda Tran, and last but not least, Yoshi the Parrot. This has been a Data.
All right, that was fun. Thanks to all you guys and all the listeners. Like the kids say, like and subscribe and all that.
Skeptic
until
production.
next time, this is the ending of the first live stream. We didn't talk about what happens now.